Okay, build stuff. Welcome back. How you all doing out there? So it's my great pleasure to welcome to the Build Stuff virtual AC/DC stage somebody. So there's a lot of folks in the dev community who they do software development alongside something else. I know we got some folks here who do development and magic. They do development and yoga, development and music. Next speaker is somebody who does a sideline flying 787 jets around the world for British Airways. .NET developer, airline pilot, IoT enthusiast, done some amazing things with 3D printing and kind of connecting virtual technology back into the real world in all kinds of interesting ways. Telling us all about how he built a flight simulator out of an old hamburger van, wasn't it, Cliff? The original fuselage chassis for the thing?
Pretty much a burger trailer that you see outside your nightclubs, or used to see outside your nightclubs.
So please welcome to the Build Stuff stage how he built a BA flight simulator out of a burger van, Clifford Agius.
Hi everyone. Thanks Dylan for the intro. As Dylan says, I'm an airline pilot for British Airways, and I'm going to talk to you about how I've taken some .NET, sprinkling the IoT, and rebuilt the British Airways Mobile Flight simulator. You can see it there in the image. That's the finished article. After we finished building it, we got a transit van driven by our tame racing driver Barry, or Stick as we call him, because Stick was taken. And he tows it around all over the UK, Europe, Ireland. It gets around to many events. It's primarily used for STEM events, so for teaching engineering, mathematics and science in schools. Also at air shows. We go to all the major air shows across UK and Europe to promote the British Airways brand, but also sales marketing now using this to promote sales and corporate events. But I'm going to talk to you about how we've gone about building this. A bit about me, just to fill in, as from what Dylan says, I fly the 787, the classic fantastic jet around the world. You can see an image there of the flight deck, the 787. I'm a senior first officer, so I sit in the right-hand seat, and the captain sits in the left-hand seat. 787, wonderful aircraft, and you've got head-up displays just at the top of the windows there. And when I'm not flying a plane, you'll find me huddled over a laptop somewhere in a coffee shop somewhere around the world, writing .NET code. I mainly work in Xamarin, so that's mobile, or MAU is soon to be renamed. And the IoT spaces is mainly where I work. I'm not doing that. I'm constantly tinkering and playing with electronics at home, out cycling with my family, etc. But it's enough about me. Let's talk about this simulator. Not moving on my slides. You still there?
I'm still here.
For some reason, I'm not moving on. There you go. It was.
We got the next slide now.
There you go. I'm back. Technical difficulties. Yeah.
Experienced a little turbulence there.
Yeah, a little turbulence. There's no emergency here. Nothing to see. This is the trailer and the simulator as it was back in early 2010. You can see it's quite tired and old looking compared to the image you just see. It's just simple things like the fact that to get in the simulator you have to duck your head to make sure you don't bash it on the top here. The simulator that used to be in there was what's called an FNPT2 trainer, which is basically a light aircraft trainer simulator. So that is the shape and size of a light aircraft, which is designed to be a two-seat aircraft. So that's why the curve is quite small, it's quite low, much like a car with a curved roof as such. The gap between the seats here is quite narrow. Imagine trying to climb between the two front seats of your car. It's quite narrow. The seats don't move backwards and forwards very much. These are Iveco truck seats that were in the simulator. And then the sim itself was quite old and tired. It was very loosely based on the Boeing 737. You can see the 737 mode control panel, which is used where we control the autopilot. And it had three screens behind it, and some cleverly cut out bits of metal to hide bits of the screen, and clever placements of graphics. It wasn't the best. Behind the scenes, we had an old Dell Pentium PC, which was running Microsoft FSX. A couple of VGA splitters here, which split the graphic signal out to the two displays. that we used by the people sitting in the seats to view the outside world, and then the displays that we used for the center console. So it was not good. It constantly went to air shows and broke, and that's where my involvement come from. I was an engineer in the car industry for many years before taking up flying, and that's where the electronics and software development passion comes from. So I was constantly called upon to fix this thing that broke when we was at air shows and events, because it was typically only pilots that went along. So I used to go to all the events and take a toolbox and a multimeter and fix this thing and take my laptop as well. It started to not get used by sales and marketing because the branding was off. It was breaking too often. They didn't want to put it in front of the corporate clients. It started to get a bit embarrassing at air shows, the fact that it broke down in front of people at air shows, and we'd have to, hand back the money that they're giving to us for their going in simulator. But most importantly, the biggest thing for me and the team of 8 pilots look after this year in, year out, is the fact that every penny this simulator makes doesn't go to British Airways. It all goes to charities and various charities that the team supports. And because of that, we're starting to lose revenue. You lose revenue, you can't give as much charity. You can't give as much charity. The charities then start to suffer, and they can't do the great work they do. But one of the events we do support every year, every October, is Dreamflight. And Dreamflight is a fantastic charity. They take about 150 to 200 kids that are terminally ill, or they have life-changing illnesses or disabilities that mean that life for them is a challenge. You can see here, this is a picture from a few years back. And what happens is we pack these kids with doctors, nurses, care assistants, and flight and cabin crew into a 747. We completely pack it out. So it's normally around half kids, half carers. And we fly off to Disneyland, and we give them 2 weeks holiday, just them. And the idea of this is it gives them two weeks experience of it's just them. There's no parents, there's no siblings. It's just them with their carers that they bring along, or we provide. And the family also get 2 weeks respite from having to care for this child. I mean, I've got a child with disabilities, and you love them to bits, and you'll do anything you need to do. But you sometimes need a break from that caring responsibility. So it gives the family a break, and it gives the children a break as well. I think it's going to have fun. I mean, who doesn't want to do that, eh? But we went along to an event, and what happens is they leave in October. They leave on a Sunday afternoon, but on Saturday they arrive at London Heathrow, and a local hotel at Heathrow provides rooms for them and their families. We have loads of events for them on the Saturday, and one of the events is the mobile sim, and have bands and musicians. They have magicians and animals and all sorts come along to the event. But the simulator went along this year, and it sadly broke. I managed to get it fixed and working, and we carried on again. And then this young girl come along in a wheelchair with her mum and her dad's, and wanted to have a go on a sim. But as I'm sure you remember from the picture before, it's quite tight inside. So we've got this to start off with, this step to get up, and then another step to get up there. So that's 2 foot from the ground, pretty much. In a wheelchair, that's not going to happen. So they don't levitate, sadly. Dad was offering to lift it into the simulator, but then inside we've got yet another step to climb into. Obviously, the radiator's moved out of the way. And then we've got these 2 Iveco truck seats. And so if you imagine carrying a child who's, I think, 12 or 13, and you've got to lift this child who's got disabilities between the 2 seats of your car, from the back seat to the front seat, and place her into the front left seat. It's not something that's going to happen. It wasn't something that was going to work. And until that day, it hadn't really occurred to me that the simulator wasn't really catering for people with disabilities. It was certainly mobile disabilities or mobility requirements anyway. So we kind of finished that event, went away. It was October, so it's typically the last event we do of the year, and we went back to the office and had a talk about this and said, look, it's starting to look old. Let's fix this up and do something about it. But in the back of my mind, I wanted to fix this thing. I wanted to make it such that the following year, if this girl was to come back, or another child with disabilities could come back, they could get in the sim and have a go at flying the sim. So I was just been awarded a course on the Boeing 787. There's the flight deck of the wonderful beast, plastic, fantastic. We call it that because it's made of carbon fibre, so it's mostly burnt string and glue. Is what carbon fibre is. The aircraft, or the transition from what I was flying then, the Airbus A320 to the 787, was we went and flew the Boeing 777, which is a common type rating. The type rating is the license you have to drive that or fly that vehicle. So imagine you get you have a car and you have, I don't know, you've got a BMW and your type rate to drive BMWs, but only BMWs. You can't drive any other vehicle, you can just drive a BMW. That's what it's like for a flying license. So I can fly a 787 or a 777 because it's a common rating. I can't go and fly an Airbus because all the systems are different. Now imagine that if you want to jump into your friends on the Mercedes, you can't do that, or full focus as I've got. You can't just do that because you don't know how the buttons and switches. The indicator might be on the other stalk, and the wipers are in the wrong place. That warning light means something different. So in aviation, it's all safety related. So obviously we make sure that we know how the aircraft works. So we're just moving across the 787. We just got the first couple of A380s into the company as well, and I went to a meeting to try and drum up some support from management and say, let's do this. Let's get some funding from the company to do this and promote the brand. Went along and was talking about what was going to build it as. I suggested an Airbus A380 because it's got joysticks, and the managers that were sitting around the table said, no, planes don't have joysticks. That thing between your legs, don't they? That yoke thing. I was like, no. Airbuses have joysticks. Boeing have control yokes, and Airbuses have joysticks. And the manager was like, no, they don't. Don't believe you. You're winding me up. You're pulling my leg, Cliff. And so we 380, as you can see here. There's the control sticks, and that's what is used to fly the plane. It is literally a joystick. And then that means in the middle they can have a table to eat their food on, or a keyboard to start tapping things into the aircraft systems. So we persuaded them that they had joysticks, but they sort of pointed out in their sales marketing kind of way the fact that if they thought that planes didn't have joysticks, then really it should have control column because that's what everyone expects. We pilots argued that maybe we should, teach Joe Public and our corporate clients, and more importantly, the school kids, that actually joysticks can fly planes. But they was like, no, we want control columns. So they won the fight, and it gave us a headache of how do we integrate this control column again into because this could have just been really easy. Sidewire in the joystick, plug it in, jobs are good enough, we go in. So we went away. We went and looked at our trailer again and thought to myself, well, how are we going to get rid of all this? So what we did was we completely stripped it out. We took everything out. We completely emptied everything, pulled all the wall linings off, the wall coverings, the whole lot, and completely stripped it to bits. You can see the pile of disused cables there and parts. It works quite a lot with the engineering apprentices, so it gave them a fantastic project to work on throughout the year as well. Something to really get their teeth into and be proud of doing as well. Once we stripped the trailer up, we started to fit in the new 787 parts, which were made out of sheet metal, and stuck some 15-inch LCD display panels behind that we managed to find on eBay. It's difficult to find small screens these days, so we had to go to eBay to get these. Again, apprentices, so you can see two gentlemen in the bottom left-hand corner explaining to apprentices what their task is for the day. And then they step back and let them do the work, and then just kind of call over their shoulders and help them out when they need it. We also at the time, because we just got some 380s and 787s on the horizon, British Airways was starting to retire some of their older 747 fleets, the old 747-400s. Not as many as we've retired this year. We were only retiring one or two back then a year. And they were all due to retire in not too distant future, kind of 2024, 25 was when they're all starting to really lead the business. But obviously the pandemic has brought that forward, and they've all left this year, sadly. So we went along to our disposals team within British Airways and said, get rid of all these 747s, can we get some of the parts out of them, please? And we managed to trade them to give us the throttle quadrant and the control yokes out of an old 747. Myself and Dennis, you can see bottom right image, had great pleasure in taking the angle grinder and cutting the throttle quadrant in half, because a 747 has 4, a 787 has 2 engines, so I only needed 2. So cut it in half and made two. We then spent many weeks puzzled and scratching our head as to how we're going to put some sensors on these, because the aircraft sensors, it uses 115 volts on their sensor platform, and so the frequency isn't 50 hertz or 60 hertz as you normally get out your plug. It's wild, so as the engines spool up and spool down, the frequency changes, but it's just base 115 volt AC. So the sensors weren't going to work for us in our simulators. We had to take them off and put our own ones on. We tried Hall effect sensors, potentiometers, rotary encoders, all sorts. We eventually settled on, for these, we rigged up a system and used a linear encoder to read the signals, and that was the best we could get. But it still wasn't ideal, it still wasn't brilliant, and it was bane of our life for a year or two until we changed the system. But then we got the trailer completely fitted out, and after about 4 or 5 months of hard graft and hard work by the engineers and apprentices and myself, we got it to look something like this, which looks just like the 787. It looks fantastic. We got 3 projectors, they're classroom projectors, so short throw classroom projectors that sits up behind the ceiling here, which is why this cutout looks like this, and we project on 3 flat panel screens. We tried to do a curved display, but didn't have the time or the funds, and we couldn't quite work out the way to build and design it the best to make it work. You can still see the step here, but we come up with a solution to that as well. And then what we also do is we gave it to our paint bay, a fantastic paint bay to paint the aircraft every year. You see out on the line, and you jump on when you come on holiday with us or a business meeting. And we gave our sales and marketing, they had some apprentices as well that were from university, and we gave them the task of basically branding this thing, and this is the branding they come up with as well. So it looks fantastic, it works fantastic, it's all new computers as well. So we then had it across at Dreamflight the following year. You can see our engineering team went back and built a ramp for the wheelchair users as well. So you can see in the top left image there, we've got a nice ramp, and it says 27 left because that is what is drawn on the runway at London Heathrow. 27 left. There's 2 runways at Heathrow, you've got left and right. Westerly direction, 27s, easterly direction, the 09s, because that's the compass bearing. You just take the last digit off. So Heathrow runway is a bearing of 272 is the bearing, so just lock the last number off and it becomes runway 27. So 27 left, they drew that on there, so the wheelchair user can come up the ramp, and you can see this young lad in the bottom corner here had an amazing time, and I'm not ashamed to say it brought tears to my eye to see him going to the sim. He was so over the moon. He was the first person to pitch up in a wheelchair and to use the sim. So the left-hand seat has now got these aircraft seats out of the 767 that retired, and we managed to steal those as well. And we got some rails purpose-made for us by our engineering team to slide the seat. Normally they come back and go to the side, but this one comes back 2 meters and allows, it's got just shy of 1.5 meter space, so wheelchair users can come up the ramp, go around this guardrail so nobody falls out, and then can wheel their wheelchair up to the flying controls and have a go at flying the aircraft. And it's an amazing experience. We've also added in on the floor a little plate that they can ride up onto with their wheelchair if they're quite short, like this young lad was. He couldn't see out their windows, so we went back and for the following year made a little plate for their wheelchairs to ride up onto as well, so they can see out the window as well, so the correct height. So we try to think of everything and make it good. But how does this work? How are we building this? Well, we have, as I said, we've got 3 PCs in the back of this now instead of just the one. We've got the instruments PC, you can see at the top there. That has all the control column inputs, the rudder pedal inputs, all the IoT inputs from the throttle quadrants, from the lights, the switches, the buttons, the dials. And it also drives the instruments displays. So they are the displays you see on we go back a slide, you can see on the here that are used to drive the model. So and the instruments PC holds the graphical, sorry, the position of the aircraft in the world, in the simulated world. So that is the master main PC. It's a beast of a machine. We had a company called Future Software help us build this, and it's a fantastic gauge machine with some pretty serious hardware inside. We have an instructor's PC, which is basically a dumb little Intel NUC PC, and that has a touchscreen, and that is just running the Instructor Station software, which controls the whole system. And we have an external view PC, which has got 3 big NVIDIA graphics cards in there, each of them driving a projector. And then we have some edge blend software called FlyLC, and Norwegian bit of software which drives and does the edge blend software that you see on the output there of the projectors. They're all connected over the network using some software called WideView, and then we also have a 4G connection to the trailer and a mobile sim in that, which means that we can connect to it no matter where it is across the UK, Europe, to help support the pilots at the events. These are normal airline pilots; they're not engineers that go to the events; they're just normal line pilots, captains, and first officers. So they connect to this. We can connect it and give them support if there's a problem at an event. Either myself, if I'm not flying at 40,000 feet doing 600 miles an hour, or the engineers back at the office as well. We then took the flight control yokes. So the 747 control yokes are these here and here, and we cut the base off. The control yokes underneath the ground in the flight deck of the 747 is quite a lot of hardware beneath there, and we couldn't fit it into the trailer because it'd be dragging underneath the ground. What we did was we built a hole in the ground. We fitted all this in, and the old simulator had this setup. This whole kind of setup here was in the old simulator. It was an old BAC 111 sim, so it was like 1950s, 60s technology for simulators down there, and it's all cable runs and it's all stretched and worn out. So we changed those for gears. I told you I'm into cycling, so we've got some sprockets and some gears, and we put those up. And we also found BFS Simulation, a wonderful small company that builds simulation feedback systems for aircraft simulators and also race car simulators. And what they do is they drive a motor for driving a force feedback, but also they have an encoder on the end. Now, the encoder allows us to take the signal from the motion, from the roll and pitch, feed that back via a analog signal and joystick controller boards into flight sim software, which then allows the user to then control the simulated world. So what we do is we use these boards from Leo Bodnar, and these are fantastic. They're about 20 or 30 pound each. So what's that? So it's about 20 or 30 euros with the current exchange rate. And this one here on the right is a button control board. So that gives you 32 buttons, just like you would on a joystick. If you've got one of these modern joysticks with buttons all over the place. And they also do ones taking analog signal inputs or rotary encoders, which then turn it into a joystick input, which you plug it in via USB and it appears as a normal joystick to Windows. So fantastic devices. Only inputs though, they don't drive output. So what we also do is we have some Raspberry Pis in the system as well, and some Adafruit feather boards in the system as well, which is just little IoT boards, again connect via USB. They connect to the Instructor Station just because we want to offload some of the stuff from the instrument station, and they're not critical buttons and lights. And then what we do is we drive those from the instructor software to drive the simulated world. So now we have these, what we've been doing is, rather than this vinyl graphic display that our paint bay put on, we've started to put in some parts. So we 3D printed a new throttle quadrant and put in some rotary encoders in there, so it works. It looks exactly like 787 now. It works like 787. On the left-hand side, we've put in the part brake and the alternate pitch trim switches, just in case the pitch trim switches don't work on the control column, or it's the backup if one of the electrical systems found on the real aircraft. On the right, we've done the alternate flap switch, overrides, and the electrical flap position selector to extend and reject the flaps. So we started to fill out with 3D printed elements and then wire these back to IoT boards and then connect them into the system. So we can start to control the simulator and fully build out this sim, just like we would in our full motion sims that we have at our training centers. But how does this all work? we have some software. Obviously, that's the hardware side. The software, the simulated world, we use P3D, which is prepared, which is made by Lockheed Martin. Back in 2000, they bought the rights to the software for Microsoft Flight Sim from Microsoft, because Microsoft were deciding going down the cloud world and Azure and the likes, and not into gaming as much back then. End of the Bulmer years, I suppose. Version 1 was pretty much rebranded as Microsoft Flight Sim. They just put Lockheed Martin Prepared 3D on there, and then they've been building it ever since. They're on to version 5.3, I think it is now. We use version 4 in the sim because it does what we need. For the outside simulated world, if you played Microsoft Flight Sim, you remember it's just got the trees and the buildings, and so we use Orbix to give us a simulated world, which is photorealistic imagery of the UK, or we go across Europe. We download the European packs as well. Put them into there as well. To get the 787 model and to get those screens that are in front of the user, we use Quality Wings 787 model. You can see there, that is an image of the simulator with the 3D rendered screens. And it looks, as a 787 pilot, I can tell you it's about 90 to 95% there as being realistic and real, as per the real aircraft. There's bits and pieces that are missing in the edges, but for the average user, gamer at home, they're not going to know the difference. I, as a pilot, can tell the difference, but that's because I fly the jet all day, every day. Well, not quite as much at the moment. And then we use, to connect it all together, I mentioned Wide View, some software from a company in Italy. Now allows us to connect it all together, but that uses software called FSUIPC. Now, FSUIPC is a fantastic bit of software. Stands for Flight Sim Universal Interprocess Communication. Written by Pete Dawson. It is some people before that, but Pete took it up some years ago and has built it up to what it is now, up to version 7, which now supports Microsoft Flight Sim 2020. Sort of. It's got some bugs and here and there because Microsoft are not fully integrated the SDK as they said they would. But how does this work? How do we do this? Well, P3D runs as a process, as we know and love in Windows, and then the software that I wrote, the 787 iOS, stands for Instructors Operating Station. Instructors Operating Station at iOS has been around way before Apple was. It's, the back 111 system had a back 111 iOS station as well, so it's been around for years. So we're not stealing it from Apple. And then what happens is FSUIPC runs another process which has this shared memory in the middle. 65 kilobytes, so it's got 16-bit pointer because of the memory array size. And then what it does is every frame that P3D draws on the screen, it jumps in at the end of that frame, grabs out the data, populates the shared memory, and then the 787 Instructor Station can jump into that shared memory and read out the data as well. Or it can write data in. Next frame, when FSUIPC does its update, it puts it back into the P3D model as well. So you can either read data out of P3D or push data into it to control the world, like a button switch, or you want to read out the speed of the aircraft or pause the simulation. So that's how it works. So just because I know you're not all C# and .NET developers, I know there's going to be some people here that are Ruby or Java or something else. Just as a catch up, and because I'm going to mention it a few times, this is direct from docs.microsoft.com. If you don't know what docs.microsoft.com is, it's fantastic. It is basically the Bible. Anyone that writes .NET software, it's got everything you need to know. But C# is what I wrote this in WPF, and it's got 9 integral types. You see here, I've highlighted the important bits in red. So a byte is 8 to 16 bits, and int is 32 bits, long is 64 bits. You've got signed and unsigned. I know I'm probably teaching you to suck eggs, but I just wanted to remind you of the byte sizes and the value sizes as I go on and talk about it, since it didn't confuse us. I want to bring everyone along, make sure no one's left behind. So this here is the table that FSUIPC has managed to work out. And what has happened is, over the course of a few years, Pete Dawson and other flight sim fanatics around the world basically went and poked and prodded and probed flight sim and see what happens to this block of memory. So if you flick that switch, did that block of memory change? Yes or no? Okay, how did it change? What value changed? And it basically works out all the values that changed. So we take a closer look. You can see on the left-hand side here, you've got a hex value. That there is the offset. So what happens is The FSUIPC connection gives you a zero position that the simulator starts at, this memory block starts at, and that is the hex offset. It then gives you the size in bytes. So this is 1, so it's 1 byte, so it's an 8-bit value, and then tells you what that is, what it's doing, and it tells you what sim it's supported. So you've got sim A, B, C, D, E, and F, and then the different versions of Microsoft Flight Sim that it goes through. So if we take a closer look, we can see here that the offsets and nav1 lock. So we can see nav1 lock and glide slope. I've highlighted those because we'll come on to those in the wee bit further in the talk. We can see the values that it is. It's a single byte. It's it's a signed byte, so it goes -127 to +127. But because Microsoft obviously had ideas, you can see here nav1 signal strength has got 4 bytes. So it's the D words that sit in there and hold no value. But when you look in the table, just here, it's only reading from 0 to 256. Some of them go up to a million, but it still doesn't fill that value size. So obviously Microsoft, when they put this table together, when there's original designers, had other ideas what they were going to do. I'd love to know what they were, but now we wanted to write this in C#, and I wanted to build this out as a .NET developer. Yes, I could have done it in C++, which is what most people do with design for FSUIPC, and I do use that for IoT projects, Arduino, seeing that. But I feel more at home as a .NET developer writing in C#. Paul Hennity felt the same about this, and he wrote a wonderful DLL, which is free and open source for you to download. And this allows you to write C# and .NET code and control FSUIPC, which then in turn controls the flight sim model. And you can grab it there from that URL. Now, I would jump into Visual Studio now and show you some of the code, but I found out when I was practicing this the other day and doing it via Skype, it caused all hell to break loose. Jumping out of PowerPoint and back in again just didn't work for me. So what I've done is I broke it out into slides. So what we'll do here is we'll take out the gear control and the pulse control signals from the tables. You can see their offsets, the hex values and their sizes. We've got 2 bytes and 4 bytes, so one's 16-bit, one's 32-bit. So obviously we need an unsigned int for the gear control, which is going from 0 to 16383, as you can see. And so it's 32-bit, and then for the pulse control, it's a U short, it's an unsigned short, because it's just actually only doing a bit. You turn on bit 0 on and off, which is doing the pause. So why they wanted 16 bits, don't know. Maybe it's because it's 16-bit pointer and they just see that block of memory space free. So that's that. So we create in C#, we create a property for gear position and pause control, and then to control the pause, all we do is just set the value to 0 and 1. Or if we want to position the gear, we do gear position dot value and give it a value between 0 and 16383. And then that gets fed back into FSUIPC, the next frame refresh, and then it goes back into the flight sim model, which then will either pause it or position the gear at that position. So it's fairly simple C# code here. It's not rocket science. So I built out the Instructor Station, and this is the Instructor Station model. This is what it is. This sits on the touchscreen just to the right hand shoulder of the pilots that's in with the person that's having to go in a sim. We set an airport at the beginning of the day, and we set a runway, and then we leave those alone. So we load those, and then they just have 3 big fat buttons. Now in the old sim, what they used to do is used to take off, and they used to have to fly the circuits and come back and land, which sounds good, but they never really got to handle the aircraft too much, and it'd take about 20 to 25 minutes to do that circuit to get them back in the right place. The pilots had to, kind of work out in the head whereabouts the aircraft was and get them to turn at the correct place and the right height, and it was all a bit messy. Those you may remember a program in the UK back in the day called Krypton Factor, which is where we used to use about their general knowledge, the IQ test. They'd go and run the SORT course, and they would also jump in one of the back 111 sim at London Heathrow and fly an approach to land at London Heathrow, and they got a score from that. Well, we thought that if we can run this and get a score out, we could give something back. The sales marketing all over this. I was like, brilliant, we've got a giveaway, something to take away with the BA logo on. This is fantastic. Do it, get it done. We want it yesterday. So I went away and thought, well, if I can get the nav1 data out for localized and glide slope, we can do this. So what we do now is this big fat button to the left. You push that and it puts the aircraft on the takeoff position. You push the one in the middle, 4 NM, 4 nautical miles. It puts the aircraft at the correct position on the approach for the runway selected. 4 nautical miles distance from the runway at the correct height, correct body angle, correct attitude, correct airspeed, correct aircraft configuration, etc., for that position on the approach. So fully configured at 4 miles, geared down, flaps, etc. And then 8 miles, you put it further out, but the gear would be up, the flaps would be just intermediate flaps and a slightly higher speed, maybe about 180 knots, which is about just shy of 200 miles an hour. But again, correct position. And then we got a big pause button, so they can unpause it and they fly the approach and it gives them a score. So I want to explain what an ILS is, because instrument landing system, ILS. Now, I'm often asked as an airline pilot, it's like, well, why is there always delays when it's foggy? You've got all these instruments in front of you. Why can't you just land? Well, I'm going to show you what it's like for a pilot sitting on board this is a 737 I've taken off of YouTube. But what it's like to be an airline pilot and fly an approach in foggy conditions. So I was told there the video was a bit choppy. I thought I had a decent internet signal. I have words with Virgin Media. And when I was talking over the top of it, but you can hear there that there's also call outs 500, 400, 300, approaching minimums 100, 30, 40, 20. They would have seen the runway in this Cat 3A approach here at about 50 feet, doing about 160 miles an hour. So the ILS, instrument landing signals that come out out of the instruments on the ground at the end of the runway. Then they need to slow down and vacate the runway. So you can see just there, you can see the amber and green lights. They are used to vacate the runway. Imagine driving 160 miles an hour, slowing down to about 70 miles an hour to find your exit off the M1 or whichever motorway is near you. In foggy conditions, it's not going to be easy. So we have guided lights to guide us off the runway. When those lights turn solid green, they're just all green, then we know we're clear the runway. We can tell the air traffic controller that we're clear the runway, next aircraft to the land. So ILS signals, how do they work? We've got localizer that sticks out and at the end of the runway, and that provides a signal. It gives on the frequency, VHF frequency, and it gives 2 modulated signals, one at 90 hertz, one at 150. If you hear just 90 hertz, you're left of the center line. You hear just 150, you're right at the center line. And the same for the glide slope is up and down as well. If you hear both together and they merge together in a single tone because of the way they're split, then you're dead down the center of the localizer and you're dead on the glide slope. Now, glide slope is a 3-degree pitch attitude, 3-degree slope down to the runway at most airports around the world. Somewhere like London City Airport in London, it's 5.5 degrees, so a much steeper approach because there's people with lots of money below the approach path and they don't want you to fly over their house and be too noisy. So that's how it works. Now, we don't, as pilots, listen to this signal. There's fancy computers behind the scenes that listen to those signals and then provide us with instrumentation on our primary flight display for us to use to fly the approach. So what we did is we put into the system that when you push the 4 nautical mile button or the 80 nautical mile button, we look into the memory locations. We take those offsets, we read them into signed bytes, and we take those offsets, so minus and plus 127, minus and plus 119 for the glide slope. And then we draw a pretty picture. So you can see here that this is the glide slope I've picked out, and this is the one I flew the other day and read out. I did try and record it to display here, but it just wasn't going to work for us. But you can see here, I've intentionally gone above the slope there and intensely below the slope there. And then what happens is it takes a bit off the score. Then I've flown quite a nice approach in the middle as best I could. And then close to the ground, we got a dip below the glide slope. Now, if you're close to the ground and you dip below the glide slope, you want to take off a massive amount from your score, because obviously if you dip below the glide slope, you're getting really low. Those buildings, those hills that are below you could get a bit too close. So we take a massive score off, just like we would be scored badly if we used to fly this approach in the simulator. I did it intentionally just to get the trace I needed. And then if you used to fly above the approach, we take a little bit of score off, because if you're too high, you're going to land long on the runway. Land long on the runway, it's not going to be enough left to stop. Certainly if it's wet and slippy, and you may go off the end of the runway, as I'm sure you've seen on the news accident reports that have happened in previous years with airlines around the world. So we create a score. From this, we then print this score out on a pre-branded certificate, which then the pilots in there signs, and you get a score from 0 to 100. And we have a Top Gear-esque kind of board that you stick your name on, and you stick it on there. And at the end of the day, whoever's got the high score gets a gift from the airline. And across the year, certainly at corporate events, those that have scored the best through the year get to come and have a go in a full motion simulator at London Heathrow, the ones we use to train in. So our simulator gets around. It's in the back of a trailer. We take to air shows, STEM events, and corporate events all over the UK and Europe. And you can see it gets around all over the place. It's been used a heck of a lot in the last few years since it's been modified and upgraded. We support fantastic charities. Higher Flight is mainly flight crew charity, so it gives the flying scholarship to disabled, which gives young disadvantaged kids and disabled kids a chance at flight in a glider or powered aircraft, and also pays bursaries to give young adults a chance at getting their private pilot's license. Dream Flight, as we talked about, takes kids to Florida for the chance of a holiday of a lifetime. And also twice a year, we donate the simulator and pilot's time. They're all volunteers. No one gets paid for any of this. We donate it to London Air Ambulance and to our friends across there, and they use it to raise money and funds for the charity that is London Air Ambulance. Often people think it's part of the NHS. It's a charity that supports the NHS, which is a national health service here in the UK. What's needed? Well, when we turn an event, all we need is a 3-pin plug or a 240-volt C-form plug, which is the blue one there, and enough power to power a kettle. We just draw 10 amps and to power the PCs and the projectors and the air conditioning unit, etc. And we send along volunteer pilots. They're all volunteers, all on days off, captains and first officers. They're all fairly quiet at the moment, sadly. At the moment, sitting around, not a lot to do, but we're not allowed to take the simulator to events at the moment. But if you want to use it at a corporate event you've got coming up, shameless plug. If you want to book us out, you've got some corporate event coming up next year, then drop us an email and look at this. It's free to book, but we charge for the event because we give all the money, as I've said, back to charity that we raise. And then highly recommend you go in the garden with the kids, arms out, airplane noise, and run around the garden and make sure you know how to fly the plane. Now you can do pitch bank in your, and it's great fun. My time's up. That's how I've gone about building a flight sim using .NET, a Sprinkler IoT, lots of hard graft from engineers, apprentices, and we now use it to promote the British Airways brand around the UK and Europe. And I think I've got a few moments for questions.
You do indeed. Thanks, Cliff. So we have one question popped up in chat from Cornel. Did you consider using extension methods or structs to represent domain concerns instead of the .NET primitives for coding in an attempt to reduce the magic?
We didn't. The DLL that Paul Hennessy's put together has made it really simple. So behind the scenes, he's using a lot of structs and stuff like that to push it across to FSI PC. And that is the advantage of using that DLL, is the fact that he's done the hard work for you. So all you need to do is literally just make sure you use the correct data type, and then you can just fill that data type. And behind the scenes, the Paul Hennessy's DLL does the graft for you. So you don't need to think or worry too much about how you configure that data. You just fill that data into that property, and it's worried about for you. It's the advantage of pulling in someone else's DLL, someone else's hard work, is they do the hard work, and you can make light work of what you need to do.
Excellent stuff. And got a question. Danny says, great talk, Cliff, as always. Do you have reactions from people or kids with cognitive or learning disabilities playing on the or using the simulator?
We do. Hi, Denny. We actually realised quite early on that these simulated environments, the ones that are best at it, are those that can shut off the outside world. We find people with autism and Asperger's and the likes are fantastic at flying simulators because they can shut off the outside world and just concentrate on the job at hand. It's quite often said that a lot of airline pilots and engineers are on the spectrum of autism and Asperger's, and because the way our mind and brain works, we can shut things off. But I've seen kids jump in this. We went to a school for kids with autism a couple of years ago, and all the kids got in there, and they were the highest scores I've ever seen. They were acing this after 2 or 3 goes, and they got used to what it was. They were acing this just because they just there and they did it. They knew what to do. It's a fantastic tool. We've also used a simulator with NHS surgeons that do robotic surgery, so keyhole surgery, and we used it for training for them as a careers day for them. They've worked out that the skills that we use, i.e. moving their hands and feet, but looking at something else, the outside world through a window, they look at a monitor and they move their hands and feet to do surgery. So, they've used it as a way of recruiting surgeons for doing keyhole surgery as well. So it's clever technology, but good question.
Fantastic. I think we're done. There's no more questions I see in the chat. Thank you very much, Clifford, for speaking. I always find that talk fascinating. I love the kind of, at the one extreme, taking an old hamburger van and doing all this stuff with salvaged aircraft parts, and then you're going down to using DLLs to hack direct memory offsets and locations. I love how it sort of covers the whole breadth of the technology spectrum, and it does it to solve a problem that is, genuinely interesting and exciting, and delivers, actually with the charitable aspects to it, is actually helping make the world a sort of better and more inclusive place. So thank you very much. Oh, we got one more question popped up. That's a good question. How is software viewed in aviation overall? Is it viewed as a nuisance, and is there any sort of general interest in software, especially considering things like the Boeing 737 MAX episode incidents?
Brutally honest, as airline pilots, we don't know. It's a button we push and something happens somewhere, and wiggly amps do wiggly amp things, and something happens and the gear goes down. We don't get told what happens between us moving the gear lever and the gear goes down. We know the mechanics of it, and we know that switch is a switch now on modern aircraft, not a big hydraulic lever like it used to be on a 747. But yeah, we know how the systems work and the computers that are there. But we're told at a very high level. If you just think about, from a prospect of, it's the cloud, and you've got literally the cloud. You've got like a computer that's doing that, and it's got a microservice that does that. That's about all we're told. The systems on board the aircraft, and we've got so many backups on backups. We've got 2 racks, a left and the right channel on the 787. Both those racks have 16 computers in. Both those computers have dual processors. Both processors have to agree on an output before it can happen from that computer. At least 2 computers have to agree on an output before it can actually action that output. So, the processors are different manufacturers, the computers are different, the software is written by different teams in each rack. So, the fact that everything has to agree for something simple as putting the gear down to action, gives us confidence in the way it works. But how it works behind the scenes, couldn't tell you. I'd love to know, though.
There's a famous anecdote about I've heard several variations, but someone stands up at a talk and they say to everyone, all right, I want you all, it's a software conference, I want all of you to imagine that you're on a plane and you're getting ready to take off, and the captain comes on and says, by the way, your team built the software that's running this aircraft. Would you stay on the flight or get off? And, most people put their hands up like, I'd get off. And there's one guy in the front, and the lecturer says, why would you stay on the plane, sir? And he says, if my team built the software, that plane's never getting off the ground. So.